Hello, I'm Eric Snodgrass, and thank you for watching this in-depth ag forecast for Australia. All right, we're going to dig a little deeper in today's forecast video and look at some other components of the atmosphere that I don't often kind of showcase to you. And I want to show you what I look for and why I look for it, and then we're going to paint a story as to where we think these next 3 or 4 months are going to go. First, we have to ask how well have the models been doing. Every once in a while, usually every other video, I do this analysis and saying like, hey, did the models at least get the previous month pretty darn close? And we're going to focus a lot on precipitation. So this is our typical, map from BOM, just showing our monthly. This is April 2025 rainfall anomalies. All right. And as I look this over, my eye just kind of identifies a few key areas. We had frontal passages that hit this part of Western Australia that at times brought meaningful rain. We know that this area was quite dry going into this, so some of the rain that came through here was a massive boom. We've watched tropical systems go north. Some have made their turn in, but overall we can kind of identify this area here that's been relatively wet and some interior places wet as well. But we've had a problem, and the problem has been in the precipitation patterns that have kind of lined this region, and mainly due to the position of big subtropical highs. That one has been off our coast here, the other's been off the coast there. We have been very limited and watched drought rapidly develop in this region. And this is some key, very key productive areas in Australia. On top of that, Tasmania has been on the drier side of average as well because of the way the flow has gone around these big subtropical highs. Now, I've got good news. They're moving. Okay, but we need to ask ourselves what that's going to do overall to the precipitation pattern going forward. So at the beginning of the month, we had a new long-range outlook that came from the European model, and this is what it showed. Now, I got to be honest, that's not bad. Remembering that when we look at these models, we're simply kind of blurring our eyes and looking for patterns. So did it pick up on this feature? It did. Did it grab that? Yes. Did it see this region wetter? It did. Now, there are pockets in here that missed. I understand that. But overall, can we find that drier stripe that comes into there? Yes. Was Tasmania a miss? It was. Okay. But overall, we try to evaluate the model performance so that I can use it again to predict out your next few months, which I'm going to do here in a few minutes. Now, I mentioned a moment ago we had this issue with these big subtropical highs, and there's something important that's happened in the atmosphere right now. The atmosphere on the whole, like the entirety of it, northern hemisphere and southern hemisphere, has lost momentum. And it did that in the month of April. And when it does that, it tends to just break up into these very large kind of circumglobal ridges. Look, there were 4 large ones that were in the southern hemisphere. There was one here, 2, 3, 4, and this is a part of the one I drew on the other side. So technically, I guess we could say 4, maybe 5 large ridges across North America. And when the atmosphere loses momentum like this, I'll just make a couple of statements. One, it tends to produce precipitation extremes. In other words, there's a whole lot of discussion on the haves and the have-nots, like just how wet it was north as tropical systems came through. And then some of the more intense storms that lined this area of Queensland are evidence of that. Elsewhere around the world, we've been experiencing the same thing. We have had, in the United States, absolutely massive flooding along 2 of our largest rivers, the Mississippi River and the Ohio River system. And I mean, flooding that is, like Genesis chapter 7 kind of flooding, just biblical in its nature. And it's been quite terrible for many, many people. But just keeping that in mind, big ridges lining our jet stream pattern, either in the northern hemisphere or southern hemisphere, when they get established, they get stuck for a while. And that's what happened in the month of April. Now, looking forward, here's another way to look at them. So it's a different color scheme. I make these maps. The previous map was made by NOAA, National Weather Service here in the United States. All right. And this map, a little bit different view, but I want you to take note of this. We're now seeing much higher pressure setting up here and here in the atmosphere. Now, that's a little bit of a difference in the position, but the problem is still evident. Big ridges still rolling across much of the entirety of the southern hemisphere. The same thing for the northern hemisphere. Look at all of these. So when it breaks up into this kind of, just persistent large ridging, I know that the atmosphere is about to cause problems for some folks. And I want you to see what this particular pattern is going to do right away here. Over the next 2 weeks, okay, outside of where we're going to watch the tail end of this stronger MJO signal, which we often talk about, putting down heavy precipitation north, it's going to be very dry. And there might be possibility of bringing in some coastal showers, but we know how these work. They just curl around here, and right along the coast, we tend to get more routine showers. There is a chance of being a little bit wetter than average. I mean, very little bit wetter than average, but most of the rest of Australia is going to go over quite dry. And the atmosphere, as I said, has kind of lost its flow. And when it loses its flow, it just tends to go toward, that look. Now, can we blame this on something, right? Not blame, but can we attribute the momentum loss to something? Well, typically at the end of a La Nina cycle, which we're right there at the end of it, that's kind of been our last big push of trade winds in the month of, April. We do notice that the atmosphere tends to just bunch up. So if you take a look right there and right there, those were our big April ridges. There's another huge one down here. And then there's one up in the North Atlantic. Now notice I'm drawing the circles a different direction. That's because the flow up here goes in a different direction, right? So these big ridges, they're the culprit. That's the result of the atmosphere giving up its momentum as this La Nina fades. They tend to go hand in hand. Now what's been interesting about it, though, is that there's still a little hint of La Nina left. And I'm going to say this, but I want you to understand this La Nina is going to be so weak, it's in neutral phase, and it'll fluctuate a lot. And therefore, we're not going to be able to just easily read the tea leaves of the ocean going forward over the next, several months. But I do not think we're going to plow right into an El Nino event, given that we still see these colors in through here? Those blues over the next 15 days represent still stronger than normal trade winds. But it is not a full-blown La Nina setup. So what I need to do is I need to think about this with respect to what's going on in our ocean temperatures. And I'm going to give you today another kind of long-range forecast based on a single-year analog. Now, last week, or 2 weeks ago, I chose these years, 96, 99. I chose 06, 08. I chose 11 and 12, and I chose 17. If you want more about that, you can watch that previous video. All that content is there. Now, this week, I'm going to talk about the ocean temperature pattern right now as it looks like 2021. And we're going to come back to that in a few seconds. But what I left you on here for is I want you to see something. The ocean temperatures right in the middle of the Pacific, where we really monitor for El Nino, La Nina, we're firmly into INSO-neutral conditions. But look at this. Look at how the atmosphere continues to give us cold water in what's called the western warm pool, but it's cold there right now. Still no strong signal from the Indian Ocean. But this is kind of the lingering effects of our La Nina. And the questions become, is the momentum that's been taken from the system going to force things to get stuck again? Because they've been stuck. Take a look at this. Going back to January, now you're going, what the heck is this graphic? All right, going back to January, what I have noticed is that we've had the best rising motion in between these lines, okay? And where's that been? That is just to the north of you, right? Right in through here, right? This is where we've had the MJO just preferring to come back to at times. Now, at times it's kind of stepped out and made these big convective waves across, but don't worry about that. What I'm trying to establish here is that this feature may continue to be with us while the La Nina fades. And to make sure that this kind of makes full sense, what I'm talking about here is best seen in this animation. Okay, now we watch these all the time. This is the newest European model forecast. I'm going to start this off at 9:30 a.m. Adelaide time on Thursday, May 1st. So welcome to a new month. Remember how I told you about those big high pressure cells? Well, there's one right there. Okay, now what we just saw though in this particular graphic, let's go back to it briefly, is where the best rising motion in the entirety of the tropics is. It is literally in Indonesia right here. And what we're going to see is as I play this forward, it's going to be high pressure cells settling in over the top of, New South Wales, Victoria, possibly parts of South Australia, Tasmania, and around the edge. And this is a very familiar pattern. We're just going to get flow like this, bringing in moisture. And to the north, the trade winds are still going, and there's just a lot of rising motion bringing in systems. Maybe some of them could be more tropical in nature, developing into tropical cyclones. But the real issue right now is that these fronts that swiped parts of Western Australia back in April are now much more limited. For example, I'm rocking back and forth over Friday and Saturday, and you notice our next front, the strongest lift in the atmosphere, is way far toward the south, not hitting this region. So that's Saturday. Let's go through the weekend. This is now Sunday into Monday. And what do you see? The main frontal boundaries are farther to the south, and all we're getting is around this high, which has slid over toward, New Zealand. We're still getting some coastal showers, but we don't see much in the way of anything else through next Tuesday, Wednesday. I mean, yeah, there's a little push of moisture coming in here next Monday, Tuesday, but here's next Wednesday, Thursday, Friday. Maybe Tasmania gets caught a little bit more in the flow, providing some better moisture as we work our way out there to May 8th, 9th, and 10th. But overall, there's a reason why I showed you that picture. Where was it? Right there. that, man, we're not looking at much precipitation as we go forward in this forecast. In fact, let's just add it up real quick. What you've got here is total accumulated precipitation measured in millimeters. Along the coast, yeah. Tasmania picking up a little bit more, but very limited. I mean, to see amounts that are down here in the 1 to 5 millimeter amount range may be better along the coast, maybe some locally very heavy rains along the coast. But outside of that, these next 10 days, we're not doing much to correct any sort of drought concerns we have that are building in key growing areas across Australia. And I'm going to continue to watch how this evolves to change this particular map. That's your latest relative soil moisture map, kind of broken up into percentile ranks. And we can just continue to see these key areas here that show up well in deficit in terms of moisture. Now, the question is, as we look out there longer, is anything coming around to fix this? Is the atmosphere going to gain momentum? Are we going to see anything that could push us in a direction that could be more, kind of offer us some more security with moisture? Well, to see that, we also need to bring into the fold a discussion on temperature. Now, for the next 5 days, it's quite warm in the interior here of Western Australia and warm along the south. But as we go from day 0 to 5 to 5 to 10, we start to see temperatures kind of rebounding a bit. What is it? It's 2, 3, 4 degrees C above the historical averages over that time frame. This is what happens when high pressure builds in. There's very, very little temperature contrast, and you need the temperature contrast to drive the wind. And you're not going to be experiencing, for most of Australia, stronger winds. I mean, the winds will be way down here to the south where they'll be the strongest. So given all of that, I want to now show you where we expect this to go in the month of May. You've already seen the next 2 weeks, but overall, the new May forecast as produced by the European model looks like this. Now notice what I talked about. All of the deepest convection, biggest storms, best rising motion is to your north. The other bit of it is to your south. And you are very much being kind of entrapped into, subtropical high pressure systems. And maybe it's an easier way to see it if I just flip this over to pressure anomalies for 30 days. Do you see what's going on here? The highest pressure is sitting here, but it's occupying more of Australia. So that's why you get the showers that come out of the coastal areas, but the deepest low pressure and therefore the best rains are going to be way to the north. We are just tucked into subtropical high pressure system as autumn goes forward, while better motion is to our north and south. Now, is that uncommon? No. I mean, we see this time of year, but it just becomes concerning if it continues to last longer as we approach, our cold season and what that might mean. So I'm going to give you a little bit more evidence on this. This is from another model called the GFS. It's gives you that same forecast out through the month of May. It looks very, very similar overall. So what does this mean? This means that I do not see any sort of drought correcting rains for these key growing areas here. And we're going to be a bit drier in Western Australia overall. Drier, not dry, not completely dry. There are fronts that are going to come through to this much weaker than what we saw in the month of April. And Baum agrees with this. So they're clearly kind of taking in some of this other information from these other models, because overall, that's a pretty consistent forecast for the month of May that you just saw. Now, what about when we get beyond this? Like, where do we take this going forward? Well, I do want to come back and show you once again, when you look at May, June, and July, what the precipitation patterns are looking like. Now, as I see this, May, June, and July, I see a bit of a wetter signal here, wetter along the coast, but overall, there seems to be a bit of a stripe right through the middle part of Australia that has this drier risk. We see more activity south and north, which seems to be the way the atmosphere is kind of flailing about as it's ending this La Nina event. But I want to give you a couple of other perspectives on the way that the atmosphere behaves and flows. And I'm going to tell you something that I watch closely all the time, and I want you to start watching it with me. Now, this is the one thing that I told you I was going to get a bit nerdy and deep on this, but have a look. What is this graphic? Well, it goes back to February and goes up to today. So this is basically a 90-day x-axis, on both graphics. Then it goes from the equator down to the South Pole and up to the North Pole. Now, when you look at this, the title tells you what we're looking at, the vertical and zonal integral of total atmospheric angular momentum. That is nerd speak for the atmosphere's motion with respect to the planet's rotation. So the atmosphere is a fluid rotating on top of the surface of the Earth, which is also rotating. And here's what I want you to see. We have just watched right now at the end of April, right here where we are, near the subtropics, the atmosphere has lost momentum. It's lost momentum in the northern hemisphere too. It didn't do this back in February, March. See, you had good momentum here, but it just lost it right there. And that loss of momentum is what's allowing the subtropical high to kind of exist. So what do we end up getting out of it? Well, our wind field is just kind of boring. Now you're going, all right, what do you mean by boring? Well, the trade winds. Let's just have a look here. Let's shrink this up so we can see a little bit better. You know, we've got this push of trade winds. That's the end of our La Nina. But there's nothing coming out of the Indian Ocean to meet it, to really stir things up. And if you just slide farther to the south, you know, where are our deepest storms? They're way down here. And we just see large areas of high pressure sitting over the top. That's that weakened flow that we're kind of talking about. But there's another piece of this I want to get to. That previous calculation looks at the vertical and the zonal into total atmospheric momentum. So can I do something for you here? I'm going to take you out of the troposphere. That's the layer of the atmosphere we live in. And I'm going to take you to the stratosphere. Now, in the stratosphere right now, can you see that in between these lines, there's net flow that's out of the west along the equator. If I go up even higher, though, we see that it's out of the east. This is such a fascinating thing to think about. Now, it turns out that those winds in the stratosphere and the winds in the troposphere, the one we live in, they interact. They actually do have an interaction on the total net momentum of the atmosphere. And of course, we got a real nerdy term for what it is. We call it the QBO, the quasi-biennial oscillation. Now, okay, I'm trying not to take you down too deep of a rabbit hole, but I want you to see this. Along the equator, we know right now that the QBO is in its eastern descending phase. What does this mean? Well, up here at 10 millibars, where I just showed you that map, this one right here, see how there's flow out of the east to the west. That is this. It's on this side of the line. Coming down to 70 millibars, it's now coming from the west again. But what's happening is these easterly winds are descending in the atmosphere, taking up more, basically occupying more of the stratosphere. Now, why even bother talking about this? As we progress through autumn, there are historical correlations between the QBO and global precipitation patterns. And here they are. Now, this is, getting almost fully into winter, but June to August, what we tend to see is we tend to be a little bit wetter where you see the purples here, and drier, kind of stripe like that. Almost looks like a weird percent sign. So I'm trying to just look for these features and what they might mean overall. And I'm going to come back to this concept at the end when I show you some of the new long-range global forecasts, okay? So I think there is a play on the precipitation pattern seen here that's being contributed to by the La Nina and its ending in the INSO-neutral conditions, and maybe something going on with the loss of momentum, which I'm attributing a bit to a bit of a change in the in what's called the QBO. Now, if I've kept you on the video this long, I'm just going to show you something neat. I told you I'm going to add another year into the mix. When we, as atmospheric scientists, look for this thing called the QBO, we look at diagrams like the one that you see here. Let's blow this up. Now, recently, the most recent time period that matches what we saw from 2024 into 2025, which 2024 had a westerly descending QBO, and now the beginning of an easterly in 2025. See it? Kind of the last time it had a similar shape to this was back in 2020 into 2021. There it goes. And there was the beginning of the easterly coming down. It was much different in 2022, 23, and plus we had an El Nino. Oh, and by the way, those other years, 96 had it coming out of 95. 99 had it 98 had it coming into 1999 right there. You know the other year, 2006, there it is. There's the pairing. 2008, there it is again. 2011 had it. 2017, little different, but it had a descending easterly phase right there. So these are part of the things that I'm using to choose these analogs. Now, we looked last time at 96, 99, 06, 08, 11, 12, and 17. Today, what I want to focus on is this. That is our current ocean temperature pattern, as measured by NOAA and NASA. What I want to show you is what 2021 looked like. Now, there's some very, very consistent themes to this. For example, in the northern hemisphere, the western warm pool was cool. There was cool water off the Baja of California, cool water in our Gulf Stream. The Indian Ocean, not a strong signal. Fading La Nina, although fading more slowly. warmth down here, warmth in through there. Now, you see all those areas I just highlighted? That's 2021. This is now. The western warm pool's got a cool splurge there. There's cold water there to there, very warm to the north. No strong signal in the Indian Ocean. There's still some cool water lingering around here, but we're very warm to the south. There's so many things about 2021 that kind of match up with 2025, which is what you're looking at. And you say, why ocean temperatures? Well, the ocean temperatures are responding to the atmospheric motion. The ocean temperatures are a coupled system with the atmosphere, and they're sometimes our best indicators on where it's going to go. And by the way, look at this. This is our Ocean Nino Index. In 2021, which is right here, we had come off of an El Nino before it into a La Nina that winter that bounced. What are we doing right now? We just came off of an El Nino that went into a La Nina that's going to bounce just a little bit. So there's other consistent features with this. Now, what we need to do is have a look at what happened during the 3-month time period ending in July. That's May, June, July of 2021. And I see some interesting things here. This section of Australia saw a bit of wetter conditions. We were a bit drier in the interior, but we were wetter. We were actually wetter in 2021 down in parts of New South Wales and Victoria and even around South Australia, Adelaide. We were wetter than our historical averages, not by much, but it's at least not a strong drought signal. In fact, as I look at this, 2021 isn't one of those years where I just saw widespread, deep, May to July development of drought. Now, we were a bit drier along the coast. That doesn't match up right now with what we've got, but I was mainly giving you that early May forecast with what's going on here. So I want to just toss this year into the mix because of one other thing. Globally, this is what the precipitation pattern looked like. Now, this was May, June, and July of 2021. And what I find fascinating about this is how wet we were in Indonesia, and how wet we were in what's called the South Pacific Convergence Zone and along the equator. But take note, we were wetter here. India had an active monsoon. We were a bit drier in places around the Black Sea. We were a bit drier here than average in South America. And the Canadian prairie in the northern part of the United States, Corn Belt, soybean belt was dry, while this part of our Gulf Coast was quite wet. Now, why look at that? I'm showing you this because take a look at the new forecast for May, June, July by the European model. Little bit of an interesting signal around the Black Sea. Wet in India. Wet in northern China. Very wet around Indonesia. Look, wet corner, wet here, but maybe drier stripe. We then see dry conditions there. We saw dry in through here. This is all panning out quite consistent with 2021. Now, there is no such thing as a perfect analog. They don't exist. In fact, you can go back throughout in the entirety of history, and because of the nonlinear chaotic behavior of the atmosphere, there is no such thing as a repeat. But I'm trying to give us a clue on maybe another year to throw into the fold that might look like what 2025 is going to look like over these next 3 to 4 months. Now, with all that being said, we're going to wait and get some new long-range guidance that's going to come out for my next video. That's going to come out from all of our major modeling centers. And I'm going to review that with you and talk to you about some threats that are happening across the northern hemisphere that I think could be important to global grains and a lot of other things. But as it stands, I wanted to put this other year in the mix, and we're going to wrap it up here. So hopefully this provides a little bit of insight, and we'll just pick this up again in another couple of weeks. Take care. Thanks.